All right, so today we're going to talk about vertex form and how to use that to describe the graph transformations or translations. So first we need to understand the basic parent functions. So our first one is y equals x squared, which is our basic parabola, has a vertex at 0, 0. Our next one is y equals x cubed, which again has a vertex at 0, 0. Y equals the square root of x, which looks like that. Y equals the cube root of x. And y equals the absolute value of x. Okay. So our basic vertex form looks like y equals, or f of x equals, same thing, a x minus h plus k, where h and k is the vertex. Okay, and this power of 2 can either be replaced with a power of 3, or the whole parentheses squared can be replaced with a square root, or any of these other parent functions. So what that would look like is, obviously the x squared is there, but this one would be x minus h cubed plus k. Y equals a x minus h under the root, and then plus k is outside. Just like the plus k is outside the parentheses here, the plus k is going to be outside the square root there. And also y equals a cube root x minus h plus k, and then y equals a absolute value x minus h plus k. Okay, so those are our basic parent functions that we're all going to be using, and the different transformations that we can do with that. Okay, so let's look at the base equation by itself. So y equals plus minus a x minus h squared plus k. Okay, and I already said the vertex is hk, all right? But the k tells us our up or down movement. Okay, and it actually is exactly as you see it. So if you see it's positive, you're going to go up. If it's negative, you're going to go down. Okay, so if the k part of the vertex tells us up or down, because that's on the y-axis, the h is going to tell us right or left movement, because that's on the x-axis. So right or left movement. Okay, but you have to remember this is going to be the opposite of what you see. Okay, so because the formula already has a negative in front of this h, if our vertex, let's say, was negative 2, 3, if we put a negative in here, it'll become x minus negative 2. 2 negatives make a positive, so that comes out as x plus 2. So if it's positive, you're actually going to go left. And if it's negative, you're going to go right. Okay, so do you see how that's kind of opposite how we usually do things on the number line? So just remember that the h is always opposite of what you see. Now this a in front tells us vertical, stretch, or compress. Okay, it'll be a stretch if the absolute value of a is greater than 1. It'll be a compress if the absolute value of a is less than 1. Now this means it'll be a fraction, between 0 to 1. Okay, because remember, we're talking about the absolute value here. So we're not talking about if it's negative, because that's a whole nother thing. All right, so let's address if that's negative. If that A is negative, it will reflect over the x-axis. Okay, and this is called vertical reflection. Okay, so this is our base formula, the one that you're going to be using 90% of the time. Okay. Okay, so now let's look at what happens if we throw in a horizontal component into this. So we have y equals plus minus a plus minus b x minus h plus k. All right, so the same thing happens here. Your vertex is still hk. K still tells you up-down movement. H still tells you right-left movement. The only new thing in this is that there is a B now. This tells you horizontal, stretch, or compress. Okay, and it's a stretch if the absolute value of B is greater than 1, and it's a compress if the absolute value of B is less than 1, again, between 0 to 1. Now, if this B is negative, it will reflect over the y-axis, meaning it's a horizontal reflection. Okay, and the same thing here. A is a vertical compress or stretch, and if it's negative, it's a vertical reflection. All right, so let's do some examples with this. All right, so our first example, let's do y equals 1/2 x minus 3 squared minus 5. Okay, so your first thing that you want to do is figure out what your parent function is. So our parent function is the y equals x squared function because of that power of 2 right there. Okay, the next thing you want to do is find your vertex, which here, okay, it says -3, but remember, it's opposite of what you see. So it's 3 and then -5. So then this means we're going to go to the right 3 because it's -3. So we're going to go to the right 3 and we're going to go down 5, -5. Okay, now the only thing we have left is this 1/2 out in front. And remember, that's going to be our A. So we're going to vertically compress by 1/2. Okay, if that was a number 1 or above, we would say that would be a vertical stretch of whatever the number is. Okay, so let's do another example. Let's say f of x equals -2 x plus 3 cubed plus 5. Okay, so again, the first thing you want to do is say your parent function, which here is x cubed. Okay, vertex is -3, 5. So we are going to the left 3, and we're going to go up 5. Okay, And remember, the absolute value is what we're looking at. So absolute value of -2 is +2. So we are going to have a vertical stretch of 2. And the only thing left to talk about is that negative. So we're going to have a vertical reflection. Okay, and that's it. All right, let's look at one that has a horizontal component. So y equals -3 x plus 9 squared minus 2. Okay, so you'll notice that this does not match our bx minus h squared plus k. Because if you'll notice, this x is by itself and the b is outside the parentheses right here. So the first thing we're going to do is we're going to have to factor out this -3. Okay, now that b is outside and the x is by itself. Now you can do all of the components. So the first one is our parent function is x squared again. Our vertex is +3, -2, which means we're going to go to the right 3 and down 2. No vertical component because there's nothing out in front of the parentheses, but we do have the horizontal component. So we're going to horizontally stretch of 3. And we also have a horizontal reflection. And that's it. All right, the next set of examples we're going to look at, I'm going to give you different aspects and you're actually going to write the equation for the graph. Okay, so here our parent function is y equals absolute value of x. Our vertex is -4, 6. We have a vertical stretch of 12 and a vertical reflection. Okay. So here we know that both of these affect our A. So we know our A is actually 12 and this vertical reflection is going to negate it. So A is actually going to equal -12. Okay, so let's start with our base. Oops. Since it's absolute value. Okay, and plug in what we know. We know that this is H and this is K, and we know that that is A. So y equals -12 x minus the -4 plus 6. 2 negatives make a positive, so our final result is that. All right. One more. Okay, so our parent function here is square root x. Our vertex is 6, 0. And we have a horizontal compress of 1/2. Okay, so since we don't have a vertical component, we can leave out A. So our base is y equals So this is our H, this is our K, and this is our B. You'll notice that B is still under the radical, but outside of the parentheses with the X. So y equals 1/2. Okay, now we need to distribute this 1/2. And since that's plus 0, we can just leave that off. And that's it. That's the equation for that graph. The last two examples, I'm going to give you the graph, and then you have to find the equation off of it. Okay, so okay, now the steps for this are parent graph. Number 2, the vertex. And number 3, find the other point. Plug all of this into the base formula. Number 5, solve for A. And number 6, write the equation. Okay, so number 1, our parent function here is y equals the square root of x, because that matches the other graph that we did on the first page. Our vertex is -4, 0. And our other point P, so P, vertex, is 0, 2. Okay, and now plug into your base formula. Now for these, I'll never give you anything that has a horizontal component on it. So just use the formula that has the A. So y equals a square root x minus h plus k. Now plug in x and y, h and k. So y is 2, x is 0, h is -4, and k is 0. Okay, 2 negatives make a positive, so we get 2. Square root of 4 is 2, and I'll solve for a. So we divide both sides by 2. So we get 1 equals a. Okay, now we go back in and plug in our a, our h, and our k. So we get y equals a, which is 1. But we don't really need to write a 1 because it's understood. So square root x minus h, so minus the -4, so plus 4. And then plus k, but that's 0, so we get to leave it off. And that's our formula. All right, one more example using a graph, and then we'll be done. All right, so this graph looks like vertex is at 2, 4. And it has x-intercepts at 1 and 3. Okay, so our parent graph is y equals x squared. Okay, vertex is 2, 4. And our other point P, now I know we have 2, but I always defer to the one that has the smaller numbers. 1, 0. Okay, now plug into the base formula. Okay, plug in x, y, h, and k. So y is 0, x is 1, h is 2, k is 4. So 0 equals a. 1 minus 2 is -1. -1 squared, +1, plus 4. And now subtract that 4 over. All right, so now that we solve for a, we just plug it back into our base equation. So y equals -4 x minus h, 2, finish our parent function, and then plus k plus 4. And that's it.